You didn't remind me to push the record button. That's the first time I forgot that in a while. Okay. But then let's just explore. So let's say exam, we looked at our sample and it kind of looked like exam B was maybe a little harder because the average was lower. So let's assume B is harder, so it's going to get a lower score. So my difference between the two could be greater than 0. B is harder, it's a smaller number I'm subtracting, and then that would result in a positive difference like we got. So let's explore that chance, because 0.2 happens twice, but what if I look at 0.2 and greater? How many dots is that, Ben? 0.2 and up. That's 5 dots. Well, how common is that? What's the chance of landing here based on the fact that we have 16 dots total? So what's 5 divided by 16? A little bigger than a quarter. A little bigger than a 0.25, right? Mention that. Oh, turn it on, Fitz. Turn it on. Turn on the calculator. 5 divided by 16. 31%. Okay, so 0.312. Okay, so this is my p-value right here. This little range of dots. And so basically my result of 0.2 has or greater. So if the one exam is harder than the other, B is harder than A. If one exam is greater than the other, we have a 31.25% chance of getting a value of 0.2. Is 31% chance, is that common or not common? How do you feel about 31% chance, Chris? What do you think? A third of the time, though. So, I mean, depending on the context, I guess. Ben, what do you think? 31? Common-ish? This is always a fun discussion. Let's call out somebody at home. Kai, how do you feel about 31% odds? Good morning, Erica.
I think it's not the highest it can be, but it's still like, it's not like super low either.
Yeah, it's not awesome, but it's over 25% of the time. Let's just remind ourselves, if there's no difference between the two exams, I should get kind of 0 as my most common value. So a lot of my data kind of naturally will fall around here, and probably eventually peak there at 0, because assuming there's no difference, there's going to be a little variation, and we're okay with that. But yeah, so let's think about it. The p-value here. That's question 3. Okay, so we just kind of talked about this, but do we have convincing evidence that one form of the exam is higher than the other? So now we have to go back to our do now. So let's pretend we did a significance test. I checked all my conditions and did all the things. Let's pretend my significance level, mouse space, as far as that goes. My significance level is 0.05. So if I'm going to compare this p-value to my cutoff point, 0.3125 is definitely greater than 0.05. So which hypothesis should I go with? Should I reject this original claim, one exam is harder than the other, or should I fail to reject? So I've got a p-value that's much greater than what I'm allowing my cutoff point to be. Cheyenne, what do you think? Do you mind unmuting yourself? Should I reject or fail to reject?
Would you fail to reject because it's not equal to 0 or something?
No, we just want to compare basically our p-value to our cutoff point. So, yeah, we're going to fail to reject just because our value that we were questioning, the 0.2, and anything greater than 0.2 was pretty common. Like 31% isn't always like the best odds depending on the context. But in the case of the significance test, where we establish that anything unusual is less than 5%, we are going to fail to reject. So we would say, okay, well, 0.2 kind of happened a lot, and so that's still pretty common value just to get that. I mean, data varies. It's never going to perfectly have a difference of 0, but generally, we're good with this. So we would fail to reject, and we would go with this one because our result is pretty common and it happened a lot. So before we go too far into a significance test, like a full-blown, all the steps, check the conditions, what questions do we have here? Because this has been a hot second with this logic of like examining a value, how likely was the value, and now what decision do I make? So questions, hit the raise hand button and you can unmute because that sometimes is faster. Or you can type it in the chat. What questions do you guys have in here? While people are typing at home or thinking about things. How you doing over there, Ben? Do you have any questions? Not yet. Chris, how about you? Feeling okay? Fail to reject or reject? Okay. People at home, how are we doing? I can't see your confused faces. So if you feel like this is okay, hit the raise hand button. Because usually in class, I can gauge things by your confused looks. I can't do that when SpongeBob doesn't, it's a picture. Saul's not blinking, so I don't. Hit the raise hand button, people at home, if you are good for me to move on, or if you don't have any questions. Tessa and Aiden are good. Saul is good. People are okay. Yeah, it's failed to reject, Tessa. Yep, because the p-value is a lot greater than what we're allowing. We're going to say any probability under 5% is weird. So 31% is like pretty okay. Okay. Okay, great. Thanks, Tessa. Oh my gosh, wait, what did I just do? Did I do something? No, I lowered Tessa's. Okay, hit a weird button. Okay, so let's go ahead. We're going to look at another example. We're going to kind of practice this again. So we're not going to do, a whole bunch of sampling things and moving cards and all that and making a dot plot. We're going to do this like in general. So we're going to use the calculator, which will kind of assume we've done this a million times and will tell us what our p-value should be. So let's go ahead and set the scene. I'm going to give you my own testimonial. This is a very passionate topic for me. I'm very food motivated. I got myself a bagel this morning. So I'm just, it's like my guilty pleasure breakfast. Other than, usually I eat bran cereal because I'm old, but okay, so let's take a peek. We're gonna look at this scenario because it allows us to have two samples and it allows us to investigate if something is unusual or not, or the difference between two samples is unusual or not. So does labeling menus reduce calories? So if you're thinking of a restaurant, back in the old days, before everything was just takeout, what's your favorite place to eat? Feel free to drop it in the chat. I got a lot of places, but what are your favorite restaurants? Where do you love to eat? Probably not Taco Bell, Chris, or you see how it's made, so it's like, ooh. You're still good with Taco Bell. Yeah, Taco Bell. I did eat Taco Bell in high school. Okay, people at home, where's your favorite place to eat? You're like, oh yeah, I'm going out. Taco Bell is your guilty pleasure. Oh, B-Dubs, Cheyenne. Yeah, I feel that. And sometimes they don't put enough sauce on the wings. I'm very particular about my sauce. What about you, Ben? Kitchen 67. I discovered them during the shutdown, I think. Right? That's on the Beltline, right? Do they have a wing special? Is that the place with, I think they got a good wing special, so that's how you don't really eat out. Black kebab. Is that Mediterranean or something? I do love a good Mediterranean place. I think on the east side, the Mediterranean places are better, in my opinion. My friend lives over there. Grace, what's your favorite place to eat? Where you? Chinese food? Just okay. I do like Lai Tai down the street there. Kind of their egg drop soup. Cane's chicken, nice. Erica, good. Anyone else favorite place? Aiden, you got a favorite place? Think about going out. It's like, yeah, I'm gonna go get, and that's what it is. I'm very food motivated, so I'm also like, taking tips on maybe where I should get takeout this week. Support those small businesses, Okay. Feel free to drop anything. So my own testimonial here is Applebee's was like, so I grew up in a small town and like Applebee's came into Big Rapids and it was like, oh yeah, like we got a place to go out to eat now. This is great. We have 3 places to choose from instead of 4. And then B-Dubs came to town and it was like, who are we? Like we're like a metropolis in Big Rapids now. But Applebee's started getting it's a good thing, but they started labeling their menu with calories. And so I like the Fiesta Lime chicken. It comes with the Mexi Ranch. And it's just, I enjoy that. It's just something that I like. And then they labeled calories, and this like chicken meal has like 1,200 calories. And so I became very sad. And every time I go to Applebee's, I get like the lowest calorie thing on the menu every time. I don't even care what it is. It's like once I see the calorie counts, it freaks me out. And that's just how it is. Now I am sure that the burrito that I get from Lindo, I don't know if anyone's been to Lindo, Mexico. It's on 28th Street. It's in Wyoming, but I am sure that burrito is like 2,000 calories. But I don't know it. It's not on the menu, so I don't know. I'm just gonna blissfully eat my burrito. But at Applebee's, not so much. So this is actually kind of a big thing because we started labeling menus a while back now, and fast food places had to start doing it because people somehow didn't realize fast food isn't really healthy. No kidding. But all right, so this is actually from a real study. So according to the Stanford Business article, Americans may eat fewer calories at restaurants if the calories of food items are labeled on the menu. To investigate this, researchers compared Starbucks receipts from locations where the menus were labeled to receipts from where the menus are not labeled. A random sample of 30 receipts. So I'm going to not highlight that in black. Let's change the color. Okay. 30 receipts from stores with menus labeled had an average number of calories of 225 with a standard deviation of 100. A random sample of 40 receipts from stores without menus labeled showed an average of 265 per receipt and a standard deviation of 75 calories. So does this provide convincing evidence that the average calories per receipt at Starbucks with a labeled menu is less than with a not labeled menu? So we're going to investigate. Let's look at the difference between the 2 receipt groups and see if that difference is a common difference we would expect, or if we get an unusual, chance of that happening. So with these kinds of problems on the AP exam, this is a really good tip. They're basically, the words convincing evidence or significant evidence is what you want to look for when you're taking that test, because there's always going to be one question where they ask you to either construct a confidence interval or do a significance test. So you're going to have to check the conditions, write the formula out, do the conclusion, all that business. But the key word to look for is significant or convincing evidence. And then the other big thing is there's going to be a giant white space. So if you see a question and then a giant white space, that should also be an indication of I need to do a lot of writing on this question. So those are things to look for. It's not just going to say, do a 2-sample t-test. It's going to say, do you have convincing evidence? And so the significance test is how you convince yourself one way or the other. So what we're going to do is actually kind of do our 4 steps with this information. So we're going to practice kind of all the pieces and parts. Please feel free to ask questions and stop me at any point. Drop them in the chat, hit the raised hand button. You're at home. So I'm just going to kind of recircle my digits here so I don't lose them, for each of our things. Okay, so we're gonna have to set up some stuff. Easiest thing to do is always your significance level. So that's always defaulted at 5% unless they tell you differently. We have to do our hypotheses, which usually we just have to read the question and remind ourselves kind of what they're looking at. So in this case, the labeled menu is less than the menu at Starbucks that is unlabeled. So what's our parameter? We have two groups. So we're just going to say we have group like A, or we could put a 1 here, group 1, group 2, group 1 minus group 2. We're looking at the differences. So this is the true average difference of, we can say calories. This stylus does not like to do eyes. Consumed between labeled and unlabeled menus. Now, the only test tip I would give you here, there's some flexibility on this, but you should say which way you're going to subtract the menus. So we're going to do labeled, because you can subtract them either way. It doesn't really matter. It's just a matter of like, you know, which one you think is less, and that's going to kind of tell you which way to set up your hypothesis based on how you want to subtract. Like label. I can't spell anything. Labeled. That doesn't look right. All right, labeled versus unlabeled. Labeled. Unlabeled, is that a word? Anyway, all right, good enough. All right, so let's go ahead. We're gonna do our, looking at a difference. So we always assume innocent until proven guilty. So for our null hypothesis, we can always say, all right, well, we'll just assume like there is no difference between the two. So if I subtract the calorie counts from each, you know, the averages, I'll get 0. For the alternative, I have to decide which way to put my sign. So this is kind of where you have to think mathematically for a second. It says the labeled menu is less than the unlabeled menu. So let's say group 1 is the labeled menu and this is without a label. So if the labeled menu has less calories, that's going to be a lower number. So I have a small number minus a bigger number. Is that going to result in something positive or negative? I have a small number minus something that's bigger. And what do you think? Small minus a big one. It's going to be small number or negative, yeah. So it's going to, so if the labeled menu has less calories minus without a label, we're going to examine that difference being less than 0. So if you were looking at it, you know, if you subtracted the other way, then you would flip it and say greater than 0. So you do want to just define how you're subtracting stuff, just to make sure people know which way you're looking at it. What questions? Yep, that's a great thing. What questions do we have? Oh, about the state part. I'll write down our difference between the two averages. We had 225 minus 265. We have an average difference of 40 calories for our measured value. Any questions in here about anything? So this is a little, you got to think kind of mathematically when you subtract. What questions do we have? People at home as well, drop it in the chat. Any questions? Anyone want to guess what's next? We're gonna have to plan something. We're gonna have to check those freaking conditions again that we've checked for weeks. But at least it stays the same, right? You know? Okay, so name of the procedure. So this time we have a 2-sample t-test because I'm looking at 2 different, very different groups and subtracting the group averages from each other. So we've got 2 groups, 2-sample t-test. We're gonna check our conditions. Ben, do you remember what some of the conditions are? All right, what do you got? Yeah, random. Yeah. Large counts are, I think, the normal condition. Okay, we got to check them all, but we got two groups. We got to check them all twice. Woo! Get excited. All right, random. It's usually stated, so we could just say there was a simple random sample. I think it was 30 receipts from labeled menus. And then we have a simple random sample of 40 receipts from unlabeled, without a label, unlabeled word, without a label. So we can generalize to all Starbucks menus. Because we randomly sampled from Starbucks, so we can then say, okay, well, our findings, at least for Starbucks, I can't do Applebee's because I'm sure people eat less calories there now. Okay, we're gonna assume, 30 Starbucks receipts has got to be less than 10% of all the Starbucks receipts from labeled menus. So sampling without replacing, the receipt, we look at it, get the calories. We're not going to put it back because we don't want to pick it twice. So we're going to assume it's less than all labeled receipts. And 40, likewise, is going to be less than 10% of all without a label. So we can sample without replacement. If we don't put the receipt back, that's okay. We haven't taken that big of a group. Let's try like that. Okay. Large counts. So you got a couple options. Either they're going to tell you the population is normal, so they could say all Starbucks receipts ever follow a normal pattern. Cool. They didn't do that. The other option is they give you some data and you see if it's kind of normal-ish. So we could have looked at like yesterday's example and went, oh yeah, there's some of our data. That looks pretty okay. Like that's kind of bell-shaped. We're good with that. We don't have that either. So then our other option is the central limit theorem. So our sample size just has to be greater or equal to 30. So that is true for both of our samples. So by the central limit theorem, our little dot plot, if we were going to make one, but we're not going to because time, and we don't have menus and receipts, but we're going to assume the sampling distribution, if we were to make one, is approximately normal. Cool. Okay, so there's our plan step. Just make sure you do every condition twice. You have to do it for each group. And then our new name, just, a t-test, but for 2 samples. Any questions on the plan step before we calculate stuff? You are going to want a calculator. So if you want to get your Chromebook calculator fired up, or you have one on a phone or whatever, or if you actually have a calculator, you're going to want to get that ready to rumble. You guys, how do we feel about the plan step? Any questions about this one? Or people at home, you can drop them in the chat. Just a lot of writing on this stuff, but okay. Oh, yep, I can go. Yep. Wait, which slide? This one? Yeah. Okay. Do you have a question, Cheyenne, on this one? Oh, okay. Let me know when you're good. And I'll bop on along. I get excited and then oh, you're good. Okay, sweet. Right. All right, the do step. So we're gonna look at our value. We're not gonna do the dot plot because it's like, that would take time. But in general, we could say, all right, our dot plot would eventually be normal because we just checked the condition for that. So we can draw a bell-shaped curve. We are kind of assuming to be true that there's no difference. So we would expect our dot plot to peak at 0. We'd get a lot of dots around 0, no difference between the calories. And then what we want to investigate is our difference, which is 40 calories, which is above 0. So we're going to investigate the 40. and we went in the less than direction. So what we want to do then, shade in the less than direction, which was a pretty significant part of my curve. And so let's go ahead, we're gonna assume our difference is gonna center at 0. Oh, the standard deviation. We did this formula with a confidence interval, but here it is again. This is technically it. You're gonna square each of your standard deviations, divide it by its respective sample size, and square root all that. But the calculator is gonna do it. We just gotta plug our numbers in. So we're gonna try to figure out, all right, what's this area? So I need to get, it would be a z-score, but the t distribution here is a little more accurate in predicting things right now. So we're going to get a t-score instead and then get our p-value. But the calculator is going to do most of it, which is super cool. So we're going to get our test statistic, which we're going to take our statistic, the value we got, minus the parameter or the true value. We're going to divide all that by standard deviation. So in terms of symbols, this is what we're plugging in, or well, we're going to make the calculator do it, but we're going to take our difference minus what we think the true difference is. So in that case, this will be 0. And then divided by this nasty formula, which is given to you. You don't have to memorize it. And I'm going to show you the calculator trick. For all of it, but we do want to just show our numbers plugged in. So we've got for our t-score, so basically examining where this is placed so I can look up or get an area. We've got a difference of 40 calories minus 0. We're assuming the true value is 0. We'll assume there's no difference. And then divided by each of the standard deviations. What was it? 175, I think. Yeah. Was it 100? Yeah. So we have 100 squared for that first standard deviation they gave us, divided by its sample size. 75 squared divided by its sample size. But you don't actually have to do that because we're going to plug it in on the calculator. So I'll wait for you guys to get some of that written down. And then we're going to fire up the calculator and just plug this straight up in there. And then it's going to do the work for us and get us our p-value and what the test statistic is, so we don't have to plug a bunch of stuff in. It's time for that. Oops, wrote that in the wrong spot. There you go. Okay, I'm gonna turn this on, and I'll take this back down so you guys can see this if you're writing. But we're gonna hit the stat button. That's where we live now. We're gonna hit the stat button on our graphing calculator. We're gonna, after you turn it on, and then you're gonna go to the tests, and you're gonna do a 2-sample t-test. So don't just do a regular t-test because that's just for one sample. But on your list, you should see 2-sample t-test. And you're going to hit enter. And we don't have data from a list. They just gave us all the information we needed, the averages and the standard deviations. If I did have just raw data, I could put it in a list and calculate things that way. But we have stats. So I'm going to hit the use the over key to go to here. And then it's just plugging all your stuff in. So group 1, we had an average of 225. Standard deviation of 100, sample size of 30, and this is your sample size. And then we got to plug the second one in, so 265, I hope it's right, 265, 75, and then a sample size of 40. Now, the only thing that is a little you got to think about is which hypothesis are we using? So I'm going to write down what we originally had, and we're going to kind of think about what it would be on the calculator, because the calculator is not set up quite this way. But if I think about it, if I think about like adding this to the other side, this is another way to write the same statement. So on the calculator, this is the option I want to pick. So the middle one here, where 1 is less than 2. Because I did the less than direction. If it was greater than, I'd pick the other one. If it was not equal to it, I'd obviously pick that one. And then we just, we don't pool, don't worry about that. That's something different. You don't need to know what that is. And then calculate. Okay, and these are our values. So it gives us quite a few things. The test statistic is negative 1.84. And then our p-value is the second thing listed, 0.036, around it. And we do have degrees of freedom given for the calculator. So we do want to just indicate that number so then the College Board or the graders know you use the calculator to get things. Because you could use that paper table and use kind of a conservative degrees of freedom, but the calculator honestly is just faster in terms of testing and time and stuff. So just make sure you write this guy down so people know that you use the calculator. Okay, and that's our p-value. So now we just got to make our decision based on this guy. Which I'm going to actually I'm going to relabel this. This looks a little off. I'm going to do my t-score instead in here. That is technically what we're looking at. So negative, oops, sorry, we're at negative 40, weren't we? Just kidding. What was it, 225 minus 265? Yeah, difference of negative 40, my bad. Like, why is this negative? Duh. Okay, sorry, yep. So I guess, okay, just kidding. So you could put negative 40 here if you wanted to show the actual value from the context, or you could put your t-score there, either way. Sorry, I didn't subtract right. It's 225 minus 265, it's definitely negative 40. Okay, what questions do we have about the button pushing on the calculator or any parts of here before we make our final decision for a 2-sample t-test? Any questions in here about the calculator or anything? Any questions at home? Feel free to drop them in the chat. Sorry. Next year, when I don't have to say, drop it in the chat. I'm going to be a very happy human, I think. If you have a question, drop it in the chat. People tossing their pieces of paper here. I'm dropping it in the chat. No more chat. I don't want to. Oh. Yeah, Grace, sorry, what's your question? Yep. For which one? I didn't calculate it because I'm lazy, but you'd have to plug your numbers in and get it. Yeah, I just wrote the formula because I'm lazy. So you don't need these two parts as long as you've got kind of your picture drawn and you're showing the numbers plugged in somewhere. You don't actually need to write the number, but I was just kind of showing you formula-wise what those are. Okay, so let's take a peek. We have a p-value. I drew my picture wrong, so it looked a little funny for a second, but we do have a p-value, which was 0.036. And what we're allowing ourselves is a 5% cutoff. So like, if a probability of something happening is greater than 5%, I'm going to go, okay, yeah, it's pretty common. Like, there's no difference in the calories on the menu. Then, labeled versus unlabeled, then a difference of negative 40 is fine. Like, when I subtract the two averages, I get that difference and it's cool. But my p-value is less than my cutoff point. So that tells me like a difference of negative 40 probably shouldn't have happened if, there probably means there's a difference. Like that difference is big enough that it shouldn't happen if there is no difference between the menus. or the calorie consumption on the menus. So this would have me going, oh no, my life is ruined. If you do, never eating the Fiesta Lime chicken again at Applebee's. So this would tell us that there is a difference between the menus, because we would reject our original claim because our value we got is too unusual to have happened just by random chance. It's, if we made a dot plot out of it and I had you guys do a bunch of stuff, we wouldn't get a whole lot of dots at -40. We wouldn't get it's not a high chance to be down here if this is the true value. So we're going to have to reject our claim, and knowing that, we'll have to eat at labeled places now. So assuming the null is true, so we have a difference of 0, we're just assuming there is no difference. There is a 0.036 probability of obtaining our result of -40 or less purely by chance. So that is interpreting our number here. We had a 3.6% chance of getting that difference. So it's pretty unusual, shouldn't have happened. Means there probably is a difference in the menus. Oh, this provides strong evidence. So it's either a strong or weak here, but since we're tossing out the original claim, we got strong evidence against it. And this is significant because now I can't eat this Fiesta Lime chicken. Oh, tossing out that claim. So that's a significant change. We're throwing out what we thought was true. So therefore, we're going to reject and conclude that labeling menus labeling menus reduces the calorie consumption. And that is a 2-sample t-test, friends. And it's not any different than the 1 sample, other than you got 2, and there's, slightly different button to push on the calculator to get that p-value. But what questions do we have about this conclusion? And this is all recorded, by the way, so you can always go back and skip around in the recording and go back to any of the parts you might need if you're studying things. Questions on anything, or I tell you what tomorrow's task is and set you free for today? Any questions about the decision-making process too? That's another kind of the logic here. There's a lot of parts, so how are we feeling in the room? What are we? Tessa does not have questions. Oh, that's an old thing. Okay, so while you're writing, hopefully, this hypothesis, this conclusion, or jotting down some notes, tomorrow it's already posted, but it's basically the check for understandings that are in your packet. So your notes thing. So you're going to try out a couple of the tests, the full 4 steps, and make sure you're good. So it's basically already there. So you've got everything already printed. There's going to be these questions to do. They are posted, and obviously I'm just looking for you to make corrections on it. So give it a try, give it an honest to goodness try, and then check the key. That'll be on the assignment, and then make your corrections. So that is it for that today. If you want to write down kind of everything we've done, this is the big one that I would write down. And I can always go back to that conclusion slide if you need it, but this is the one people tend to struggle with, remembering what to do in a 2-sample test. So remembering which way to kind of write the alternative, because you're subtracting 2 things, and then you got to think which way to flip the sign and all that. The conditions we've been doing to death since forever, but there they are again if you want to write anything down on those. But or if you want to do the formula, that is there. Slightly named, but anyway, the big one I would say is the hypotheses. That's definitely something I'd stick in my notes to make sure I know which way to flip those when you've got 2 groups. That's just kind of a little bit different. Okay, if you do not have questions, you're free to pop on off. If you are writing things, feel free to hang out. And if you need me to go back to conclusion, I can, but just let me know in the chat. Have a great day, friends. See you all on Friday.